All right, guys, a quick video on a concept that differentiability implies continuity, that if a function is differentiable, then it must be continuous. One of the interesting things about math is that sometimes things that are completely obvious, you want to go ahead and prove them, because if you prove them, then you can just assume them from then on. So the theorem is that if f has a derivative at x equals a, then f is continuous at x equals a. And we're going to actually just go ahead and do an algebraic proof. So how do we prove that? Well, definition of continuous is that the limit as x approaches a of the function f of x equals the value of the function at that point. So we're going to prove that that must be true for differentiable function f. Well, let's start by doing a little algebraic manipulation, because this implies that the limit as x approaches a of f of x minus f of a is 0. And because f of a is a constant value, this therefore implies that the limit as x approaches a of f of x minus f of a is equal to 0, because the limit of as x approaches a of f of a is just f of a. It doesn't really matter. So what happens next? Well, what I'm going to do is I'm going to multiply top and bottom by x minus a. And the reason will become clear in just a minute. X minus a times f of x minus f of a over x minus a. So notice that I haven't changed the equation. All I've done is multiply top and bottom by the same thing, which I am allowed to do. Moving up to here, what we've got next is that we've got that the limit as x approaches a of x minus a times the limit as x approaches a of f of x minus f of a over x minus a. Notice that this is 0 because as x approaches a, x minus a approaches 0. This is just the derivative of the function at a, but 0 times anything is 0. So this equals 0, and therefore we have proved true statement that that limit, if I go back, proved true statement that the limit as x approaches a of f of x equals f of a. Therefore, and you guys will never probably have seen that notation before. It's a scientific engineering medical notation called short for therefore. Therefore, the function is continuous. And since we assumed that it was a differentiable function at the very beginning, we've just proved that differentiable functions must be continuous. Differentiable, again, at that point, must be continuous at that point.